Hello everyone, myself Sridhar. I am from CSEF section. Today my topic is about diagonalization of complex matrix. Now let us discuss about the introduction to diagonalization. First, what is diagonalization? Definition of diagonalization. Diagonalization is the process of converting a square matrix into diagonal form by finding an invertible matrix P and a diagonal matrix D such that A equal to P into D into P inverse. Here, the diagonalization means is a process of converting a square matrix into a diagonal matrix by and finding inverse matrix of P and diagonal matrix D such that here the equation is given by A equal to P into D into P inverse, where A is the original matrix, P is the matrix of eigenvectors, where D is the diagonal matrix of eigenvalues. Here goal is simplify matrix computation by transforming A into D. Diagonalization of a complex matrix. Here, the diagonalization of a complex matrix is nothing but, in case of complex matrices, eigenvalues and eigenvectors can be complex numbers. Here, the in diagonalization of a complex matrix, the eigenvalues will be complex numbers and eigenvectors also complex numbers, where the key observation is even for complex matrices, diagonalization is possible if the matrix has a full set of linear independent eigenvectors. Here, the complex matrix can also have diagonalization uh, if the matrix has a full set of linear independent eigenvectors. If the matrix has a complex eigenvalues, the matrix P will have complex eigenvectors. Here, the complex eigenvalues can be determined by if a matrix having a eigenvalues, then the P will have the complex eigenvectors. Let us discuss about the conditions for diagonalization. Here, when a complex matrix is diagonalizable, here a matrix A is diagonalizable if and only if it has full set of linear independent eigenvectors. A complex matrix is diagonal only when if it has a full set of linear independent eigenvectors. A complex matrix can be diagonalizable even it has complex eigenvalues, provided it has a complete set of eigenvectors. Let us see here example for diagonal matrix. A diagonal matrix is a square matrix where all of its non-diagonal elements are zeros. It is of the form. Here we can see the diagonal matrix A equal to A1, A22, A33, A44, AN, AN and so on. This is the matrix of order n by n, and it has all the diagonal values are variables, and other than diagonal values are zeros. Here we can see an example of 3004. Here the diagonal values are 3 and 4 and the remaining values are 0. So this is known as diagonal matrix. Now let us discuss about the eigenvalues and eigenvectors. Here, finding eigenvalues and eigenvectors. What is eigenvalue equation? For a complex matrix A, solve the characteristic equation, where characteristic equation is det of A minus lambda I equal to 0 is known as characteristic equation. Here the solutions lambda are the eigenvalues which can be real or complex. Here the eigenvalues are lambda solutions of lambda, which may be real or complex eigenvectors. For each eigenvalue lambda, solve the system of equations A minus lambda I into V equal to 0 to find the corresponding eigenvectors, which can be complex. By this we can find the eigenvalues and eigenvectors by using characteristic equation. The diagonalization process. Here are the steps for diagonalization of a matrix. First, the steps to diagonalize a complex matrix. Here, the first step is finding the eigenvalues. We can find the eigenvalues by the characteristic equation. By finding the det of the characteristic equation, we can find the eigenvalues here. Firstly, we should find the eigenvalues by det of a minus lambda I equal to 0. And then the second step, find the eigenvectors. Solve a minus lambda I into V equal to 0 for each eigenvalue lambda yielding complex eigenvectors. Here for every eigenvalue lambda we have corresponding complex eigenvectors. And third step, form the matrix P. Here construct a matrix P from the eigenvectors with each eigenvector as a column. Here we can form the matrix P from the eigenvectors and then form the matrix D. Here the matrix D can be formed by place the corresponding eigenvalues as a diagonal element in the matrix D. Here the eigenvalues are kept corresponding as a diagonal element in form the diagonal matrix D. Then verify the A equal to P into D into P inverse of A, so that we can know the diagonal matrix D. Here is an example of diagonalization. Here, the diagonalization example with complex eigenvalues. The matrix here given is A equal to 0, 1, minus 1 and 0. Here, the step 1, we should find the eigenvalues by using the characteristic equation A minus lambda I equal to 0. Here we can find the eigenvalues. Here we found that lambda equal to I n minus I. In step 2, the eigenvectors are found by from using lambda equal to I and lambda equal to minus I. Here we got eigenvectors v1 equal to 1 and I and eigenvector v2 equal to 1 and minus I. And from this we can construct the matrix P and D. Here P is 1, 1, 1 and minus 1 I minus I and the D is I 0 0 I. Here the diagonal matrix D equal to I 0 0 I. We can verify this by using the formula A equal to P into D into P inverse. We can see here diagonal matrix. A square matrix is called a diagonal matrix if a non-diagonal entities are all zero. The main diagonal can be constants or zeros. The diagonal matrix must fit the following form. Here we can see an example of diagonal matrix D equal to D111, D22, D33, D4, so on, DNN, and remaining all are zeros. This is known as diagonal matrix. Now let us see the important properties of diagonalizable complex matrices. Here, the key properties are similarity. A complex matrix A and its diagonal matrix D are similar matrices. Here, the matrix A and D are similar matrices. And eigenvalue multiplicity. That algebraic multiplicity of each eigenvalue must match the number of linear independent eigenvectors. Here, the algebraic multiplicity of eigenvalues must match the number of linear independent eigenvectors and the complex conjugates. If A has a complex eigenvalue, their complex conjugates may also appear depending on the matrix structure. Here, the complex conjugates can be can be determined by the complex eigenvalues. Their complex conjugates may also appear depending on the matrix's structure. Applications of diagonalization. Here are some applications of complex domain matrix powers. For a complex matrix, diagonalization simplifies raising a matrix to power a power n equal to p into d power n into p inverse. Here we can see that a power n equal to p into d power n into p inverse. Then quantum mechanics. Eigenvalues represent measurable quantities and eigenvectors represent quantum states. Then differential equations. Diagonalization helps in solving system of linear differential equations. And then vibration analysis. In engineering, diagonalization can simplify the analysis of the systems with complex eigenvalues such as vibrational modes. Special case Hermitian matrices. Title Hermitian matrices and diagonalization. Here definition of Hermitian matrices is a matrix A is Hermitian if A equal to A power H, where A power H is the conjugate transpose of A. And the properties of Hermitian matrices are Hermitian matrices always have real eigenvalues and can be diagonalized by a unitary matrix instead of just an invertible matrix. Applications. If in quantum mechanics, Hermitian matrices represent observable quantities with the real eigenvalues. Here, the Hermitian matrices formula is A equal to A power H is known as Hermitian matrix, which is A power H is the transpose of A, where A equal to A transpose is known as Hermitian matrix. The final conclusion about the diagonalization of a complex matrix. Here, diagonalization of a complex matrix involves complex eigenvalues and eigenvectors. Matrix can be diagnosed if it has a full set of linear independent eigenvectors. Diagonalization simplifies matrix computation, including powers and solving differential equation. Here, the diagonalization of a complex matrix is done by using the complex eigenvalues and complex eigenvectors. And the matrix can be diagonalized if it has a full set of linear independent eigenvectors in a complex matrix. And a diagonalization simplifies matrix computations, including powers and solving differential equation. And this is all about the diagonalization of a complex matrix. Thank you.